Hi, Anissa.
Hi, John. I'm actually driving on my way home, so I'm not at my computer yet. I'll have my mic muted until I get in.
Okay.
Okay, I think this is the correct one, right? Hi everyone. Anissa, how are you? Can you hear me?
Yes, I'm actually in my car driving. I'll be home in about 30 minutes. So I just told John I was going to have my mic muted, but I'm doing okay. How are you?
Okay, okay. Yeah, as you might probably observe, my voice is not so good right now.
Yeah.
I've been suffering for like a week now of um of cough and yeah, flu in
Oh, no.
general. So
You
sorry,
taking any?
Anissa. Yeah, I think you're getting dropped. Anissa. I
Oh,
think it's because of
I
the
was asking if
internet.
you were taking anything. Take some.
I'm taking this. I'm not sure if you have it in in the U.S. Strepsils.
I'm not sure. I don't take like over the counter medicine. I do
Oh,
remedies and herbs and stuff at home.
yeah. Unfortunately, I don't have the time to uh like prepare those stuffs. But yeah, I think one good home remedy is honey
Yep.
and tea, right?
That's the one. Honey tea, add some onions and some
Yeah,
lemon and some
yeah.
garlic.
Well, the thing is, currently the humidity is just really extreme. So I think the reason I got this is because we dined out last Sunday in a floating cottage.
Oh,
So it was so hot. It's not only hot, it's very humid. Like
right.
sweating would not really cool down your body. So I think well, my family members were also sick because of that. It was really well, Southeast Asia is just sweltering right now.
Oh yes, the
Yeah,
trop.
there's a heat wave.
Oh. Okay, come on.
So
Sorry, I'm.
hopefully you can understand me because of yeah how coarse my voice is right now. But
Oh yeah.
yeah, we have John anyway. John is very knowledgeable about the topics. Hi Nia, welcome to the meeting. How are you?
Hi, I'm good. How are you?
You're doing good.
Thank you. I hope you
Uh,
feel
we're,
better.
yeah, yeah. Thank you very much. Where are you staying, Nia?
I live in Seattle, Washington.
Oh, okay, okay. Yeah,
Yeah.
you sound very young. How old are you?
I'm 24.
Oh, okay.
Yeah.
Yeah. I thought you're like uh, 18 or 19 because of
No.
your voice.
Yeah, everybody said I looked younger than my age, look wise.
Yeah, yeah. And also your voice.
Yeah.
Uh, okay, let's wait for the others. So there will be those times that I'll be sort of squeaking. So please try avoid avoid laughing. Okay. Um, yeah, there will be like this high pitched noise every time I speak. So we'll be starting SQL today. So we just finished Microsoft Excel, and hopefully everything was clear.
I have a question. So I wasn't here on yesterday's class. Do we have a
Mhm.
test on Saturday? I've seen
Yeah,
in the team.
you have an exam on Saturday, Mia.
Okay.
Supposedly the exam should be today.
Uh,
However, I felt that your time would be insufficient if we decide to go with the exam today. So typically the exam is being assigned every Saturday anyway. So I think we just need to follow the schedule. Okay.
okay.
Okay. Hi Hasiba, Jeff. How are you guys?
Hey, how's it going, Jeff?
Yeah, my
Hello.
voice is not so good right now. So again, there will be
Wait,
times that I'll
not so
be
good. Why?
squeaking.
What happened?
I'm suffering from flu. It's just the
Oh, I'm
weather
sorry.
here
Sorry to
in
hear that.
Southeast Asia. It's sweltering. The heat index is almost 50 degrees.
Already? Wow.
50 degrees Celsius. Yeah, imagine that. So this
That's
is
ridiculous.
record
That's
breaking.
that's like that's like that's like that's yeah, that's like straight up food.
Yeah, 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 yeah. And in fact, not only the heat index that makes it worse, it's the humidity. When
Yeah,
you're
no,
outside,
I personally cannot survive in humidity.
yeah, um, sweating would not even cool your body down. So that's crazy. Everybody's getting sick right now. It's not only here in the Philippines, Southeast Asia, it's getting baked. So I think this is one indication of the climate change. So
Yeah.
yeah, extreme temperatures. So anyway, I think we have everyone now. Grace, welcome to the meeting.
Hello.
There will be times that I would sound like Chipmunk, okay, like Alvin the Chipmunk. So apologies for that. Okay, I'll do my best. Okay, I'll do my best. So this is a new session. We'll be starting with SQL, and I think Jeff is already familiar with the topics that I'll be discussing here. So
Yeah, and I'll just sit back and kind of get a recap.
yeah, 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 like a refresh for you. So let me share my screen. Um, yeah, let me just look for the correct file. Okay, there we go. Let me slideshow from beginning. Okay. So before we start, I want to ask you, um, how was the Excel session? Um, do you think that it is too fast or too slow or just right? Were you able to still remember the things that we have gone through with Excel? I want to have your feedback, guys. Please be honest, so that for the upcoming sessions, I'll be able to adjust. Again, my goal here It's not just to finish the cohort. I want to provide value to you. Okay. There will be upcoming projects that I'll be doing with my clients, and I'm planning to onboard you. See how a statistician do a project. Okay. So if you have time, I will be scheduling it. I'll be showing you the data set, and I'll be showing you how I do things for my clients. So in some way it is like a mentorship thing. Okay. So that in the future, if you'll be given a task, you know how to you would remember how would I attack the problem. Okay. How would I start and plan and strategize in doing data analytics. So guys, how do you see it? The Excel session. And maybe while you're thinking, I'll just adjust my AC. I'll be back in a while, in a minute. Okay. Anyone? Maybe we can go first with Anissa. Anissa? I don't know. Anissa is driving. Sorry. Yeah. Nia says, let me check the checkbox. For me, it was easy to understand. Um, yeah, I think there were points, there were instances during the discussion that I think I haven't done it in the like simplest way, in the clearest way. Um, so yeah.
I did want to comment. For
Yep.
me, it was fairly simple to follow along, but as a learner, I am more like a hands-on. So
Mhm.
the better parts for me when we were able to kind of go through like the labs together and
During the
sit.
labs. Okay.
Yeah,
Perfect.
it's better for me to learn
Mhm.
by actually doing. The lecture part is a little bit harder for me. So for me, like I was going back and looking at the video
Yeah.
versus
Yeah.
being
Yeah.
pick it up during class. That's why I didn't really have too many questions. It was kind of easier for me to uh, write the questions down and then try to figure along as I go, if that makes
Yeah. Yeah.
sense. So yeah,
And yeah.
that
Thank
was
you very
my.
much, Anissa, for
I
that.
did enjoy it.
As well.
I was easy to follow though. Yes.
Yeah. So I think me and Anissa, we share the same way of learning things. I have a very short attention span. I'll be honest with you with that. And
Exactly.
also, I'm the kind of person that needs to go over and over this concepts so that I can explain it to myself in the simplest possible way. So what I do is um, I do tons of exercises. So I think that should be how we should be proceeding, especially with the upcoming topics. We will make the labs heavy, okay, so that you will gain that hands-on experience more. That's I think one way to adjust for the upcoming sessions. How about the others? That's a thank you very much, Anissa, again, for pointing it out for saying that.
I felt
How
it
about the
was very informational and like really good at keeping the class together at a specific pace. I did feel like the exercises, the amount was like the bare minimum. And
okay?
so like
Yeah.
Anissa's point about like being able to learn and then
Mm,
practice as like two different like modes of your brain. And so I
yeah.
think it would have been neat if like during lecture or the discussion, it would have been like a different example than pulling up the lab work,
I see. I see.
to
Okay.
kind of increase the exposure to the
Mm,
kinds of questions, the types of tools, things like that. And
I
that like
okay.
and like along what they were saying like lecture can be like simply just following along
Hmm.
versus like trying to do it ourselves in a separate way, separate
Yeah.
section.
Yeah. So for the upcoming sessions, it would be better if we also have these practices. Like I'll be giving you some time to do it by yourself, maybe like 5 minutes to 10 minutes, and then ask your questions if you've understood the process, the concepts clearly. And then in your lab, we'll make it a bit higher in terms of complexity and difficulty, so that you'll be stretched, right? You'll be
Yeah,
challenged.
I like that idea.
Yeah, yeah. Okay, perfect, perfect. I like that setup also, because I want to put myself in your position. I want to make the most out of it. So I love this suggestions from you. Okay, okay. John, can you take like some notes because I think the points are really important. So how about the others, guys? I need your suggestions or recommendations and thoughts on how the first 2 weeks was or were done. So my strength is SQL and Python. So with the coding, I think this would be easier for me. So this would be something that is well more natural as compared to Excel. So yeah, I don't want to make it too difficult. Uh, I don't want to like burn your enthusiasm. So I want it to be just perfectly balanced. Okay, things that you would really need um, joining as a junior data analyst. Jeff, do you have anything to say? Okay, I think Jeff is away. How about Hasiba? Hasiba, do you have any comments? And don't worry, be honest with me. I'm that type of person that really
Yeah,
accepts
so I
constructive
learned a lot
criticism.
because, as you know, I'm very basic to data
Mhm.
analytic and Excel and everything. For me, practice works better
Okay,
as well. But of course, we would have an idea when you explain everything. We would have an idea in our mind to so what to do with the practices.
so I think yeah, there's a consensus among us uh, that's really about the worksheets and practices, right? So we'll put more emphasis to it. Okay, we'll have more of that during the next sessions. So perfect. Thank you very much, guys. Anissa, do you have anything to say or to add?
Oh yes, I'm just gonna add. What I realized is I think that this because of the information that we are learning, I think trial and error is just a
Hmm.
little bit more effective because it helps like register.
Yeah,
For
yeah.
me, it helps
Experience.
register in my brain. Like yesterday when we were doing the labs with John, I was
Yeah.
getting like half of the answer, but not fully. So I needed to see, where it was going wrong, and then
Okay,
Grace was
okay, yeah, yeah.
show us another method to kind of shorten the formula but still apply the same rules. And so,
Mm,
just kind of being able to see that um, was very helpful as well. So I kind
okay,
of like the
okay.
guided where we're able to kind of, go along with you guys and call
Mm,
out what we're doing, and you're able to see, if we're you know following along or anything. Because when you ask if we're following along, I feel like we're all going to say yes because like we are there with you.
yeah,
But in
yeah.
regards to like the knowledge actually sticking, I don't necessarily, I know for me I have to put my fingers to my keyboard, and
Mm,
it sticks like that.
yeah. I always do that even when I'm teaching at the university because well, we have experienced teachers that are just talking with the board, right? For me, it's important that what I'm saying is being received by audience clearly. So, well, English is not my first language, so there might be times that I'll be looking for the best words to say. So I always want that feedback from my audience if what I said was clear. So it's also a way for me. For example, most of you are silent, so it's an indication for me that maybe something's wrong. Maybe there are concepts that I've not explained that clearly. So it's a gauge for me, a sort of gauge to sort of adjust. If it's needed to do a separate video explaining that thing, that would be better. Okay, because I'm really looking for quality. Really looking for value. I want to say that once you finish this cohort, every topics that we have discussed, you have understood well. Okay, we are focusing on value, not just getting the certification. Because most companies, okay, you have the certification. Now you have to explain to me this concept, show to me this process, and I think that's more important. Okay, instead of that paper. That paper is just a like how should I say this? A plaque that you have persevered and you have this you have completed this, but uh the lesson should stay. The skills should be there. So again, thank you very much, and we'll be doing this after SQL. Let's see if everything is way better before we transition to Python. So okay, let's start. So again, this is a completely new session, and this are today's plan. We'll be discussing relational databases. Okay, and we'll be setting up mode. Mode is our primary platform in learning SQL queries, and we'll be doing SQL queries, the basics, like selecting a table or selecting a column from a specific table and applying some basic filters. Okay. And of course, we'll be having a practice in lab. So typically, in like 5 sessions or like in previous cohorts, this thing can be accomplished in 2 sessions. Okay. So probably we can finish the relational database today because I want to solidify the idea. Why do we need to study SQL? Okay, maybe during your college, maybe during your high school days, you were studying so many things without asking, why do I need to study this? I think that's very important to ask yourself, why do I need this? Okay, so I always put emphasis to that, making sure that whatever we are discussing, you know the reason. Okay, you know the essence of it. So let's start. What are relational databases? So a database is an organized collection of data. And there are many types of databases. We have the relational. When we say relational, the tables in your database is connected or are connected with each other. Like if you can remember when we do Power Query and Power Pivot, we established a connection between the tables. Okay? We have established a connection using the staff ID and the employee level. In that way, we were able to create multiple tables. Okay, so relational databases, again, the tables are related with each other. Not necessarily all of them, not necessarily, because as you can see, as you can probably remember, the employee table, the salary table, and the records or transaction tables from the previous example that we had in Excel, only two of them are really connected with each other. It could be like if you have tables A, B, and C, only A and C and B and C are connected. But since there's a connection between at least two of them, you are able to tap the information from the other table as well. Okay, so that's the idea with databases. Your tables are related by a certain column, by a certain information. Then we have the document and we have the graph and NoSQL. So these things you can think of it as, for example, dictionaries. Okay, you can think of the graph as networks, and with NoSQL, basically, if your tables are not related, okay, that's the time that you will have a NoSQL database. So there are software like MongoDB, which is I think the most famous one for NoSQL. But there are others as well, but think of it as key value pairings. Okay, value pairings in which those records are not represented in terms of tables, but with a setup similar to a dictionary. You have a key and you have a corresponding value. So databases are usually controlled by a database management system. So one of the most famous for relational databases is Microsoft SQL Server, and we'll be using that um, in this section so that you know how to create a database from it. You'll be seeing how to create records and tables, how to do SQL queries with it. Okay. Any questions, guys? Any questions? So our focus for the SQL section would be relational databases. Okay. The others will not be discussing it, as we want to know, since most of the organizations they use relational databases. That's our main focus, and it's very easy to transition once you know how to navigate through relational databases. Navigating through the others would be much easier. So we need to master at least one first. Okay. So let's compare spreadsheets versus databases. I've said before that we should not treat spreadsheets such as Microsoft Excel as databases. Why? Because databases can hold much more data. If Microsoft Excel, the usual one, it can only hold to a million observations, okay, a million records. And at the same time, um, you have limited data manipulations with it. And oftentimes, it's very slow, especially if you try to manipulate, if you try to do data transformation um, with a large data set. But of course, you might argue, Jeff, you've told us about Power Query that allows us to handle more. And that's something that is unique with Microsoft Excel, with Microsoft. They look for a solution to mimic what a database could do, handle and transform large data set. But still, in comparison with what a database can do, it's still minor. Okay, it's still misty as compared to what a database can do. And aside from that, you've noticed that if you work with spreadsheets, once you open the file, everything will be loaded at the same time. Imagine if you have like 30 sheets, that would be that would be very large, and it would require so much computing capacity of your device, of your computer. However, in a database, you can only pull those relevant data that you need. So for example, instead of loading everything, you can do a SQL query that extracts only a subset of your data set. Okay. So in that sense, it's more efficient. If you don't need the others, why load it? But if you're using spreadsheet, then you don't have any choice. you need to load everything once you open the file. And the good thing also with databases is there would be a sort of blueprint to understand how records are related with each other in a very structured way. Okay, so there are so many benefits. Also, one is security. Uh, with spreadsheets, I'm talking about the basic spreadsheet. Um, it's very easy to commit mistakes. It's very easy to manipulate the observations, the records. However, with databases, you cannot do that uh, easily. Okay. Oftentimes, once you pull the data set from the database, that's the only time that you'll be able to transform and manipulate it. But with the actual environment, usually a team or just a single person, the database or the data engineer, the database manager, would be the only one to have access in manipulating the records in the database. So in terms of security, if you're a large company or even a medium company at least, you'd be choosing a database because you would be prioritizing the security of your information. In a spreadsheet, it's very easy to share and leak the information. Okay, so I think that's the main advantage of a database. It's about security. So what is a relational database? We have seen this. Okay, in a relational database, all data is stored in tables. That's the main difference. If we go back here, document, graph, and NoSQL, those are in key value pairs. Okay, but in a relational database, it's very straightforward. It's very intuitive because we have been immersed, we have been experienced looking at records in a tabular form. So each row contains a record. So each of this row contains a record for one tree, a record for another tree, and so on for this particular example. Each columns contains the attributes of the data. So the attributes refer to like characteristics of the records. Okay. So in this case, we have the tree ID. You can think of it as like um, a way to identify the identity of a tree. And you have the species in there. Both are oaks. No, no, no. The other one is ash. I'm not very familiar with trees. But yeah, I'm familiar with oak, but with ash, I'm not really familiar with it. Now we have the condition. So all of these columns, all of these attributes, this referred to the characteristic of the record. So you also have here the plant date, which is self-explanatory when the tree has been planted. And we have another table right here. Okay. Let me just pull up my Epic pen. So this is another table right here, which refers to another record. This time we have the work done, okay, the work done on the specific trees, and also the date in which the work has been done. So this is a separate table. You can call it table B. This is table A. And how are these tables related? So we identify the species and the condition and the date the tree was planted using table A. And we have another table that identifies the work done with it, with each of the trees. So you might be thinking, okay, Jeff, why do they have different tables if they are referring to the same thing? Because uh, in most cases, there are different people managing the records for each of the attributes associated with the tree. Sometimes in a company, there are different departments. So it would be totally chaotic if they would be having access to the records of the other department. So they should be only responsible for the records in their own department. So that's the reason why you have multiple tables. Okay. But again, as you can see, this is tree ID one. Okay. So this refers to the same tree and the work done on it. So it was trimmed based on the record first on January 5, 2022. And then the next one was February 14, 2021, or February 4, 2021. The same tree. So in this way, we can see that the link, okay, between these two tables would be the tree ID. And in most cases, if you imagine a school database for the student record, the tables are linked via the student ID. Okay, the student ID identifies the particular student, and it also identifies the courses or the subjects that the student have taken. Okay, and also um, like it could be that there will be another table that identifies the professors. Okay, like there is a possibility that three professors are teaching the same subject but in a different period. Okay, so you can imagine it that way. Those tables are being linked together by this student ID. And you can think of another link. It could be um, uh, the subject ID, right? Because as what we have said earlier, there are there is a possibility that there are more than one professors teaching that. So you can easily think that if you want to identify the subjects associated with the professor, that should be identified by the subject ID. So, for example, subject ID 1, it is for economics. And you have another table that identifies this professor's teaching economics. Okay? So, there could be another table that identifies employee ID. Okay? So, there would be a unique identifier for each of these professors, linking it to another table, academic rank. So, in that way, you would see that there would be this web. There would be this web of tables in your database. Do you still follow, guys? Is everything clear? Maybe a virtual thumbs up will do. I can feel my throat is slowly giving up. So I think we need a break, maybe after an hour. So, yep, let's see. What is SQL? SQL stands for Structured Query Language. Okay, it is a language for storing, manipulating, and retrieving data in databases. So typically, people would be saying that SQL is used to pull data from the database. But generally, SQL is the programming language to communicate to the database, whether it is for the purpose of storing, manipulating, and retrieving data in your database. So that's it. That's what SQL is. You might be thinking, okay, SQL is very simple, very straightforward. The answer is yes. So SQL is built with the idea that it follows the English language. So if English is your sort of native language, this would be very easy for you because as you can see later, the structured in which it is formed, like a query is formed in SQL, follows the structure of the English language. So it will be very easy for you. Okay. You can write SQL in DBMS or database management software, and it can also be used in scripts written in other languages. For example, before I've used Python to write SQL codes. Like um, I've wrapped Python in my SQL codes. So what I did in the past was I'm pulling up this data set from the database and doing Python to pre-process data in order to fit it in my machine learning model for training. So you can do that. Okay, it's very adaptable. So I have here a very basic SQL query. So basically we are selecting. So the select is a SQL query. The asterisk here is used if you want to get all the columns of your table. Again, this this asterisk if you want to get all the columns. Okay, all columns. So that's how you do it. And then from customers, this is the table. This is the name of the table, customers. And here, this is called a filter. We are saying that, okay, get all of the columns from customers table where the customer ID is 1. Again, select or get all the columns from the customers table where the customer ID is equal to 1. That's very straightforward, right? So you would be expecting that all of your records would return only those rows with customer ID equal to 1. It's as simple as that. Okay, but again, it could become very complex, especially if um your filter it requires you to do like more complex things. Like it's not only that the ID must be 1, it should be everyone should be males, something like that. So it could get very complex depending on which subset of your table needs to be pulled. Okay. Any questions, guys? Any questions? Any questions? Can I get a thumbs up if everything's clear?
Yes.
Okay, perfect. Thank you very much. Thank you very much. I need that response from you guys. Okay, what are the benefits of SQL and RDBMS? Might be thinking, Jeff, you've mentioned this different types of databases, but why are we focusing on relational databases? So these are the reasons. Okay, it's to manage multiple tables in a database. It's easy. I kind of forgot the word easy there. It's easy to manage multiple tables in a database than manage multiple spreadsheets. Again, it's a matter of security. Imagine you're working for a bank and you screw the records. That would be a pain. Okay. Um, some time ago, I was working with this former Google data scientist, and he told me that when he was still a junior data scientist, he unintentionally deleted a section of the record. This was from like a banking database. Fortunately, every database has a backup. Okay, has a backup. So um, that's one good thing. Also with database, typically they have backups and they have this like layers of security before you can like delete uh, uh, records. So that's one advantage. Again, it's about security. Okay. You have the ability to join related data records, and we'll be discussing this during intermediate SQL. Um, and actually, we have done it. We have done it with Power Query. Okay. The way I connected those tables together, basically, that's what's going on when you do SQL joins. Of course, there are so many types of joins, but the basic idea is that you'd be joining on related columns. Jeff, is there a way to join unrelated columns? The answer is yes. We can stack it together. We can combine it or join it side by side. Okay, so it depends on your it depends on your goal. If all the columns in table A are unique, and so as with table B, you can just join it side by side and form this bigger table. It's being done. Okay, but if, for example, there are related columns that you can use in order to link it together with the other columns, that would be better. But there are times, of course, that um, there would be records in the other table that is not existing on the other table. It would give you tons of missing values in your rows, in your records, and we would be seeing that once we discuss SQL joins. And SQL commands are reproducible, and it can be integrated into scripted processes like Python, Java, and so on. In fact, hackers use this. Um, if you're familiar with SQL injection, it's being used in cybersecurity. And RDBMS systems can store massive amounts of data and allow for granular control over data access. It's more secure because, yeah, instead of loading everything, you can just look for or pull um, a part of it. Okay, you don't need to see everything or load everything. So here are some benefits of SQL and RDBMS. Questions, guys? Any questions? No. Okay. Perfect. Awesome. So let's talk about ERDs. So when you have a database, it's easier to navigate through it if you have a map because it could get very complex, especially if the organization has like multiple departments and they are maintaining multiple uh, tables. It would be very chaotic. It would be very complex. Imagine a web of tables. Let me show you an example. Complex tables in Power BI. Let me just give you an example. Hmm. Relationship diagrams. I want to make sure that you are seeing what's on my mind. So let me look for a good example of it. Maybe this would do. This is not actually very complicated. You can see it. Um, this is not that complicated, but at least you have a visual of what I was talking about. Imagine having hundreds of tables, all connected with each other, and others are not connected with the other tables. So this is a visualization of an ERD, an entity relationship diagram. It identifies what type of relationship one table has with another. It identifies which tables are connected with each other and what are the keys, what are the common columns that are being used in order to connect them. It would also give you an idea what is the type or what we call um, I forgot the term. Um, I forgot the term. Let me think. It's a technical term. But basically, what it does is I forgot the name. Okay, it identifies how many records, how many instances in one table is associated with the other. Um, yeah, my memory is failing me right now. I'm forgetting the name. John, Do you remember the name of the term? I have it in my lecture, but for some reason I'm forgetting it. Like, what do we call the different types of relationships in ERDs? Like one to many, one to one. I'm forgetting the term.
Is it cardinality, sir?
Cardinality. Perfect. Thank you very much. Sorry. It's a sign of aging. Okay. I'm still young, but okay. Maybe it's very easy for me to forget things. So cardinality. Okay, the thing that I was mentioning earlier, like identifying how many instances in one table is associated with the number of instances in the other, that's called cardinality. Okay, so we'll be talking about that. But again, what I want to highlight here is this could get very complex. Imagine having hundreds or even thousands of tables linked with each other. So it's the same thing. Uh, if you're trying to look into a blueprint of a building, the bigger and the taller the building is, the more complicated the blueprint will be. So the blueprint would allow you to to see where are the like electrical lines, the pipelines, the columns, and so on. So it will give you like a top view, a bird's eye view of the building. So that's the same thing with ERDs. It's a blueprint. It's a blueprint of your database. You would see there, okay, what are the tables that I have in my database? It's also a way for you, for example, you're planning to create a database. It's always best to have an ERD so that your database would be structured. Other people would be understanding it very easily, very quickly if you have a diagram, if you have a blueprint of your database. Okay? So let's see. And aside from that, also the data types for each of the columns, for each of the records, would also be identified by your ARD. So it's really like a complete guide of your database. So let me close this one. Let's go back to this. Do you follow, guys? Was that something clear? Was that something clear, guys? So let me go through this. ERD or entity relational diagram is a type of structural diagram for use in database design. An ERD contains different symbols and connectors that visualize two important information: the major entities, the system scope, and the interrelationship among these entities. Typically, they don't discuss this in boot camps, in DA boot camps. However, I feel, okay, that this should be discussed more. This should be treated with higher importance before even jumping into doing SQL queries. Being able to read ERDs is essential for you to create an effective database. Okay? So let's see. An entity is a definable thing or concept within a system. It could be a person, okay? It could be a role. For example, there could be an entity for John, okay? And that entity could have things associated with John's or attributes like John's height, favorite food, color of the eyes, color of the hair. Okay, so it could also be an object, an invoice, a concept, be a profile or event. Okay, so note that in ERD, the term entity is often used instead of table, but they are synonymous. They are just the same thing. Entity, if you want to sound a bit more technical, but essentially you're just referring to table. Okay, when people call it entity, they're just pertaining to tables, nothing special. But that table could be, again, these things. person, object, concept, event. Okay, it could be even like just an abstract thing. So when determining entities, think of them as nouns or names. In ERD models, an entity is shown as a rounded rectangle. Look at that. It has no corners. Okay, it's the corners are rounded. So that's how you create an entity. And I'll be sharing to you a software that I use in creating entities. Okay, later. So with its name on top, so this is a, an entity for teachers or a table for teachers. It could have names of teachers. It could have heights. It could have information such as length of experience in years. Okay, loans, example, subjects taught. Okay, it could be, or well, most often the subjects taught would typically be on another entity. Okay, so the ERD example below shows an example of an ER entity. Again, it's just a table. So the thing that I've shown you earlier, where was it? Uh, Let me just go back to it. You can think of those tables earlier as entities. You might be saying, Jeff, why do this thing, okay, show corners like a perfect square? This is from Power BI. So, but if you want to be technically correct and you're defining an ERD, should not be like this. But again, every software they have this kind of theme or way in presenting those tables. So with Power BI, it's just the same thing as with what we did with Power Pivot. They used, since they are just a product of the same company, they use the same thing. Okay, let's talk about another thing, entity attributes. Think of this as columns in your tables. You have a customer table, and these are the columns. These are the attributes associated to it. Simple as that. Okay? Jeff, would I be putting a column that is not associated with my table? The answer is no. It doesn't make sense. Every column that you have in your entity or table must be related to it. Like here, customer ID, customer first name and last name, address, telephone, and so on. All of these are columns. And you have here the data type. It is integer of max length of 10. A varchar or a name, a string of maximum length of 255 characters. Okay? so those are entity attributes. Those are just columns in your table. Do you follow, guys? Okay. So you might be seeing, okay,
Yes.
Jeff, what are these things? Thank you very much for the response, guys. Appreciate it. So you have here a key logo, a key um, sign. Okay. So it means that the records in this table are identified by this ID, the ID of the customer. Okay. And you can use that with another table, for example, their transactions, right? You could be having an entity right here referring to transactions of this particular customers. Okay. So every customer could have multiple transactions, right? Multiple transactions. For example, if the period covered in your record is for a year, and this is like a database for a grocery store, then how many times in average do a person go to the grocery store? It could be like once a week, so that would be how many weeks, or just once a month. So That would be 12 times. And there would be 12 records in this table, in this transaction table, associated to a particular instance in your customer table. Okay. But they cannot share. Like, for example, is there a possibility that um, there would be the same ID for different customer? No, that doesn't make sense. It should be unique. Okay. So we will be talking about that, the primary and the foreign keys, and say that, okay, for the primary key, it should be unique. And it makes sense. Imagine a school database wherein more than one student share the same student ID. It doesn't make sense. So a primary key must be unique. Okay. So let's say primary key, also known as PK. Okay. I think we should continue the discussion of the primary key after the break. I think I need a bit of a break. Maybe 15 minutes. Would that be fine, guys? I'm losing my voice. I'm starting to feel it. Would that be fine, guys? Let's do a quick 15-minute break. Not a quick. This is relatively long because I hate to give breaks. This is just only a 2-hour session, and but apologies. I really need it right now. Okay, maybe I get some water or something
Get
that
some
would.
hot tea. Jeff, sorry.
Yeah, yeah. I have honey in the pantry, so I may want to create like a hot tea or something. So let's be back after 15 minutes. So be back after 15 minutes. Okay. Are you guys back? Can we start? Okay, perfect. Okay, okay. I think everyone's here now. Um, so let's continue. So as I was saying earlier, the primary key, it is a special kind of entity attribute. It is a special kind of column that uniquely defines a record in a database table. Typically, it's just a ID, um, but in our previous example, we have seen that aside from being an ID, it could be like levels of a record, like employee level. Okay, it could be that you have tons of employees having the same level, and they have um, tons of records associated to them. Typically in sales, you have that kind of setup. So in other words, there must be not two or more records that share the same value for the primary key attribute. This again, it doesn't make sense. It doesn't make sense to have a record, the primary key, that is identified or associated with two records. It would be very chaotic. So the example that we have here, so we have a table for product with the primary key attribute ID, okay, and the preview of table records in the database. So the third record is invalid because the value of ID PDT dash 002 is already used by another record. So as you can see, if you are trying to create a database for or a table for products in your database, then it makes no sense to have different products share the same ID. It doesn't make sense. In most cases, it won't allow that. It would throw you an error. If you try to create a record um, with like the same key with different inputs, then your database management system would throw you an error. So, but at least you know, well, it might be a bit self-explanatory, right? If you think about it, that it doesn't make sense to have the same identifier for different things. So that's the primary key, and it's typically identified by this key logo that you can see right here. And we have another type of key, which is called a foreign key. Okay. The thing is, a primary key could be a foreign key of another table. Again, let me reiterate that a primary key of one table could be a foreign key in another table. Let's see. Let's see. Okay. So it is also known as FK, like an acronym for it. It is a reference to a primary key in a table. It is used to identify the relationship between entities. Note that foreign keys need not be unique. That's one key difference. Okay. When a primary key becomes a foreign key in another table, it doesn't need to be unique. Why? Because as you can see with this example, okay, multiple records can share the same values. So with our primary key in here, it identifies the actual names of the companies. So we have here Hello World Tech, which has an which has a name of M-01 and ABC Technologies M-02. However, these companies could manufacture many different products, right? The Hello World Tech could have many products manufactured by the same company. So that's what we are seeing right here. In another table, in another entity product, you would see that, okay, in this, there are two products, okay, PDT001, PDT002. Again, this is a primary key in the product table, but this is a foreign key that relates, okay, which companies or which companies, yeah, manufactured the products. So Tiger T7 Bluetooth headphones and DD-027 in-ear headphones, black, are both manufactured by what? The manufacturer that has this M-01 ID. And that is, if you look at the manufacturer table, that is Hello World Tech. Okay? That's the reason why a foreign key could be non-unique. Because that's the reality. You create a primary key to identify exactly which records are associated with it. But when you use it as a foreign key to the other, it could have multiple instances, such as this. Okay, and you can think of it as the same thing with school database, right? So the student ID is unique for each of the student. However, if you use it as a foreign key in another table, such as subjects, then one student could have taken like as many subjects as the course requires. Do you follow? Does that make sense? So the primary key originally in this manufacturer ID becomes a foreign key in the product table as identified by this logo. Again, the primary key in the manufacturer table becomes a foreign key in the product table. It identifies which companies, which manufacturers manufacture the particular products. Okay? Does it make sense? Does it make sense, guys?
Yes.
Okay,
Making
perfect.
sense.
Thanks, Grace. How about the others? Please be honest. It's completely fine and understandable to be confused. So let's maximize the time and ask questions if necessary. And as you can see, there's a logo right here. There's a connector. We'll be talking about those different types of connectors. So basically, this connector is saying that there is a one-to-many relationship between the manufacturer table and the products table. An instance, this could be translated this way. An instance in the manufacturer table can have multiple instances in the products table, as what you can observe in this example right here. So one instance, M-01, has multiple instances in the product table. Okay? So this M-1, 01 rather, has two instances um, in the manufacturer, or rather in the products table. Okay? I hope that's clear. You should be able to once you look at the ERD, once you see these things, it must be immediate. Okay, it must be immediate that you know the meaning of this, given this logo and this. Okay, everything must be clear. Now let's proceed. Let's talk about relationship. Again, we're dealing with the relationship diagram, so it's important to understand what do we mean by relationship. The relationship between two entities signifies that the two entities are associated with each other somehow. And in fact, I cannot think of the existence of a relationship if two entities are independent. It could be similar to saying that you have a relationship to the person, however, the person doesn't really know you. So it doesn't make sense, right? Um, a relationship must be something uh like it's a two-way, right? It's a two-way. Relationships are two-way. So in ERDs, it means that two entities are associated with each other somehow. It could be one to one, like one instance in one entity is associated with one instance in another table. Let me think of an example. It's difficult to think of one. Hmm. Let's think about a certain product that has that. So for example, you have a product, say headphones, and the other table identifies the available colors, manufactured colors of that product, and you're only manufacturing red. So if you would be linking the relation, those entities, product table and colors table, um, it would be um, only one to one, because all of your headphones would be red. So of course, it doesn't make sense to put that in a database. However, if there's a possibility of adding different colors in the future, then it would make sense to have that in your ERD, in your database. So it's completely possible to have that kind of relationship. And in fact, we will be discussing that. Okay, relationship cardinality. This is the thing that I've forgotten earlier. So there are different ways to do this, but the most used is this Krauss-Foot method. So this is the exact thing that I've used that you have seen earlier. This thing right here, it looks like a crow's foot, or maybe not, more like a chicken foot, right? But anyway, it's called that way. Okay, it's called that way, a crow's foot. So cardinality refers to the possible number of occurrences in one entity, which is associated with the number of occurrences or instances, as I call it, in another. So, for example, one team has many players. When presented in an OR ERD, the entity team and player are interconnected with a one-to-many relationship. Okay, so so here are the different cardinalities. Okay, so typically this thing are interchangeable. Oftentimes, people would be using this thing to signify one-to-many. Okay, um, is it possible? Let's go back to the example earlier. Is it possible that there's a zero to many relationship? I guess in this example, it's not possible because it's not possible that a particular product would be in the products table without even like without an identified manufacturer. So it could be just one to many in this case. Is the least that we can have. Like that particular product or that particular manufacturer only manufactures one product, right? Like say there's another company here, M-03, which has the name XYZ Technology, that only manufactures say mouse. They only manufacture mouse. So that would be like a one to one relationship. So something like that, if you think about it that way. But of course, with the existence of other records, it would be like a one-to-many relationship. Because, for example, with the Hello World Tech, it has at least two instances in the product table. So just think about it that way. If my entity, okay, can have multiple instances in another table, then it is uh, a possible one-to-many relationship. But Jeff, is it possible that you have a many-to-many relationship? Yes, through an existence of a linking table. The many-to-many relationship can only exist if there's a linking table in between. One table has a one-to-many relationship with this, and this other table also has a one-to-many relationship with that table. So basically, this would appear as a linking table. And in that way, manufacturer and this other table could have a many-to-many relationship. But it doesn't exist like in pairs alone. It always requires a linking table to to form a many-to-many relationship. In fact, um, Power BI before 2016, I think July 2016, was it 2016? Yeah, I think if my memory serves me right, before July 2016, you can only formulate a many-to-many relationship through a linking table in Power BI. And they look for ways. They look for ways in which, even with just a pair, you can link You can formulate a many-to-many relationship. So they look for solutions. They look for ways to do that. But in a classical ERD, it won't exist without a linking table. And we have an example for that. Don't worry. Okay. I'm just maybe you're just thinking that if it's a possibility, the answer is yes. So let's go back to this. So do you need to memorize this? The answer is no. Okay, because it's very easy to see, right? It's very easy to remember actually that one pertains to a specific stuff. Typically, in entities, this is the most common. Um, what are there else? This one is also pretty common, but in special records, you would observe this just like in the case that a manufacturer only manufactures one product. So yeah, you don't basically what I was trying to say is you don't have to memorize this thing. Okay, you don't have to memorize it. You can search for it. What I want to instill to your mind is the idea. Okay, the concept, the thinking behind it, the reasoning. So let's see one-to-one cardinality example. So here you have one user assigned to one profile in the other. It's not possible that one email is associated to multiple profiles in your user profile table. So it's just one user, one user profile, which is in most cases the case, right? In most cases, it is such that that email is associated to one profile. If you try to use the same email for like a different profile, it won't work. I think you have seen that in like registering for something in the internet. It would say that this email is associated with other profile or other account because in its database it only has a one-to-one cardinality. One user is assigned one profile, or rather, I should say specifically one email as one user profile. So it could be that that user creates another email. Okay, so you would say that, okay, Jeff, it could be that the same user would have multiple profile in that sense. Yes, but here specifically, we are very particular with the email. Okay, does this make sense, guys? Is it something clear?
Yes, sir.
Okay, thank you very much for the response. So this is very straightforward. Okay, very straightforward. Okay, moving on. We have one-to-many cardinality, which is well um, the most common. Here we have a department with another entity student. So one department could have many students. As simple as that. Okay. Questions, guys. Questions. Questions. Is it possible that the student has no department? No, right? It should be at least one, right? At least one department has one student. In fact, sometimes it's not even the case. They have the minimum. Like in order to form a department, you have to have at least five students. For example, the course is not really that famous. Like for example, archaeology. So they have like a minimum number of students to open that department. Or I might be wrong in saying that archaeology is not famous. It could be. But what I'm trying to say is that it's completely possible that It could be that there's a minimum number of instances um, in order for something to exist. So, yep, I think this is something that is very easy to understand. Now, how about many to many cardinality? So this is the thing that I was mentioning earlier. It's completely possible to have a many to many relationship through a linking table. So a many to many relationship refers to the relationship between two entities x and y, in which x may be linked to many instances of y and vice versa. The figure below shows an example of a many to many relationship. Note that a many to many relationship is split into a pair of one to many relationships in a physical ERD. So this is a linking table, everyone. As you can see, it only includes foreign keys. Okay, so student ID could have multiple instances in the student course. That's the typical, right? Like if you're a student, you could well mostly be taking multiple subjects for your course. And at the same time, this course, right, can be associated at least one, could oftentimes many to the students. So multiple students would be taking multiple courses, and multiple courses are associated with at least one, but could be many students. Does it make sense, guys? I think this is very straightforward. At least in this example. Sometimes it's not really that clear if you maybe look it in a different perspective. So I think a school database is something that's really a good sample for this, a good example to visualize it. Questions, questions. So this is how you form a many-to-many relationship. Is it a requirement that you only have foreign keys in your linking table? The answer is no. There's a complete possibility that there are other attributes as well existing in your linking table, and it doesn't affect the many-to-many cardinality. It would still exist. Again, you should always remember how many instances in one table is associated with how many instances in the other. It's the easiest way to identify the cardinality. And if you see something like this, it is safe to assume that these tables have many to many relationship. Okay, it's something that is almost consequent. Okay, perfect, awesome. Let's see. Let's proceed. So this is a recap. Again, here are entities, even an abstract thing you can put into it. Anything that you can create records of, that can be an entity. um, Attributes, those are just columns, variables that are associated to your entities. You have the relationships, the connections, right, with each of these tables, which is very self-explanatory. And we have the cardinality, the type of relationship, which is very important. It's very important that you know how many instances are associated with each tables. Okay. Um, and you have these different types of notations, I should say. These different types of um, visualization for cardinality, which you can easily search for. You don't have to memorize that. In fact, as data analysts, our goal is just to have a glimpse of the structure. The 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 job of creating a database is mostly assigned to data engineers. They are the ones designing this. They are the ones maintaining this. So of course, since we are also an actor, okay, in the database, we should know how things work, how like how the structure is being built, and other associated details. I think that's very important. So we also have the keys, right? The primary and the foreign keys, which is like unique identifier for the case of the primary key. It identifies the instances in another table, but in that other table, it would be a primary key because there's a possibility, like for a one-to-many relationship, many instances of that key exist in the other table, which is the typical record, right? A typical setup. So that's it basically for ERD. But I've also included here best practices. I want things simple, okay? And it's also the same with ERDs. Keeping it simple. Again, the goal is to have an overview, a bird's eye view of the database. If you make it messy, if you make it extremely complicated, then it would add more confusion instead of clarity. So the easiest way to do it is to keep things simple. If you cannot put things like in a simplest way, you don't understand it uh, completely. So that's my gauge. If something can be done in the simplest possible way, that's the best. Even in problem solving, like as a product manager now, the CEO would be saying, "Jeff, we have this problem. Can you recommend me solution?" I always think, what is the simplest way to do this? Because oftentimes that's the least expensive. Simple things. Well, um, we tend to underestimate simplicity because we feel that if it's simple, we haven't thought hard about it. But in reality, keeping things simple makes perfect sense. Okay, makes perfect sense. Make it straightforward. Use meaningful names. So this is exactly I've encountered this before. They put like how should I say this? Not so obvious names because typically they would use shortcuts for the entity names. Like instead, of course, they will just use CRS. They want to make it very, very short. So make sure that if you would be deciding to use shortcuts, um, it would still obvious that you are pertaining to this thing. Okay? Don't make it too short that it's losing its identity. Okay? And to tell you honestly, there are there are databases I encountered in the past that it doesn't make sense how they named it. I mean, it's not even it's not even um how should I say this? Common sense. Okay, even even thinking it through common sense alone won't give you any idea on what it is. So make the names meaningful. Okay, should be related to what records or columns you have in there. Maintain consistency. Okay, there are naming conventions like snake case, um, camel cases. We'll talk about those as we proceed along. But there are these conventions in naming your attributes and even variables. Okay, take feedback. Typically, you may need the help of the data engineer or even the team in order to understand. Okay, what have you what have you done with this database? Can you give me a quick tour of what are the things in here? Why is why is it this way? Like why is it one to one cardinality? So that's one thing. Okay, oftentimes so many so many issues can be easily resolved if we just maintain consistent communication. Okay, leave behind the ego, leave behind the well, so many are experiencing um imposter syndrome. Okay, if you try to show off like in coding, it's understandable that you cannot know everything and memorize everything. Googling is actually a skill. Using AI is actually a skill. So if you don't know something and you can remember it, seek help. Okay, search for it. Don't be an imposter. Okay, be honest with yourself, that would make things very, very comfortable for you and for the others as well. Instead of burning so much time pretending that you know, seek for help. Okay, utilize your tools. So, well, it's easy as may it sound, but the level of ego of other people becomes a barrier to it. So, this early at this point of your career, you should you should maintain open communication with your team members and even your supervisors. So document assumptions, like clearly document any assumptions made during the ERD creation process. If um, you're not the one who created it, then you definitely need help, okay, to identify these assumptions. So I think, let's say, do we still have time? Yep, we still have time. Let's continue. So solve exercise one, creating an ERD for a university database. I have here, consider a university database system that manages information about students, okay, students, courses, and instructors. Create an ERD based on the following: student, attributes. These are the columns, guys. Columns. This is the table. Okay. Course. There's respective courses. For example, John is taking BS Mathematics. Okay. Apologies for that. Relationships. Okay. Or rather, instructor first before relationship. So before you dive in and create this ERD, you should be familiar with the relationships of these different entities. So students can enroll in multiple courses, which is, I think, in some cases, they're not allowed to do it. I mean, it depends on the university. Each can have multiple students enrolled. This is the typical case. Instructors can teach multiple courses, yes. So, for example, me, I was teaching mathematics, I was teaching economics, and business analytics when I was still teaching in the university. So it's completely normal to see instructors teaching multiple subjects because typically um, specializations are interconnected with other um, how do I say this, with other fields as well. Okay, like economics to business, economics to statistics, and so on. Each course can only have one instructor, so which is a bit odd. Okay, so this is a bit odd. So typically, um, there are setups in which one course they have multiple instructors, but basically this is the relationship that we're looking at. So let's see how will we create this. So I've used here this this thing. John, can you share this to them, please? Thank you in advance. So this is a tool that you can use to create ERDs, which has the same theme that we talked about in class. As you can see in here, this is a linking table that makes the relationship between student and course one many to many, and we have the instructor which has a one to many relationship with the course. Okay, so here, um, this is the exact solution to the thing that I've shown you earlier. Instructors can teach multiple courses, but each course can only have one instructor. So one instance here, okay, is associated with multiple instances in here, but each of these course can only have one instance in the instructor table. Okay, that's how you do it. Again, Each course can only have one instructor, but an instructor can have multiple courses. So that's the exact relationship that we have. And this is a linking table, enrollment table that links the student with the course. And multiple courses, right, and have multiple students, and multiple students can enroll in multiple courses. That's what we have. If we go back to the thing earlier, we said that students can enroll in multiple courses, and each course can have multiple students enrolled. So basically, we are referring to this thing, to a many-to-many relationship between this course and student table. Okay, I think this is a very basic like representation of that thing. But in order to see if you've understood it well, I have this for your lab. So this is supposedly, um, well, yeah, I've assigned it as your task in lab, but I guess there would be additional. Let me stop sharing for a while. I don't want to spill the answer. No, I actually deleted it here. Yeah, let me show it again. So your task in your lab is to create an ERD for a retail store inventory management system. And guys, it's totally fine to be confused. Remember, it's your first time creating an ERD. Allow yourself to be a beginner. Ask questions if necessary. Okay? Like for example, allocate 5 minutes. For example, you encounter you're confused. Allocate 5 minutes of complete focus. And if still after 5 minutes everything doesn't make sense, you ask John. John would be there to help you. But allow yourself to focus. Again, focus is a very sacred thing right now. Okay, you have here your social media. I deleted my Facebook in my smartphone because I've observed that sometimes it's quite automatic that I'll be whenever I touch my smartphone, I would be looking to my news feed. So I have that realization. So I've deleted Facebook long time ago. So if I want to do Facebook, I've been needing to use my laptop. So it's a way for me to win myself from using social media. So again, focus is a very sacred commodity right now. It's a very rare commodity. So 5 minutes of pure focus. If nothing makes sense, no idea, ask John. Ask for help. Okay. So it allows your brain to process all of the information that I've shared to you. It would build those connections, those ideas, and you'll be surprised that when you see it again, the puzzle starts to make sense. Okay, it would connect almost instantly. So what's your task? Imagine designing an inventory management system for a retail store. Create an ERD based on the following requirements. What are the tables? Product. What are the columns on that? Product ID, name, description, and price. Okay. Category, another table, another entity. The attributes are category ID and name. Okay. So you have a primary key in the category. It should be the case, yes. Because if you think about it, categories identify specific items, right? It could be category for refreshment. You have Coca-Cola, Pepsi, juice, and so many things like that. It could be category for crackers, for bread. So it's perfectly understandable to have an ID on it. Supplier. It's also understandable because supplier ID, for example, one supplier gives you like multiple products, multiple items, right? You have the contact info in there. And I've given you the relationship to make your life easy so that you won't avoid assumptions. Okay, you would avoid assumptions rather. So if you have the relationships clear, you don't need to do any assumptions. But if you don't have that, that's the time that you would create assumptions, like this could have that and so on. But here it's clear. Each product belongs to a single category. It gives you the cardinality. Category can have multiple products, of course. Each product is supplied by a single supplier, which is in reality, it's not the case. Okay, it's not the case. I think it's visual thinking that your supplier would be like unique for each of your product. Doesn't make sense, but still, we have it here to allow you to think. Okay, and the supplier can supply multiple products. Okay, a supplier can supply multiple products, which is the typical thing, right? So, for example, I'm a supplier. I can supply you with frozen goods. I can supply you with bread. I can supply you with any other products you can think of that you would be needing in your store. So, hmm. So that's your thing, your um task for the lab today. So the intention of this is to see if you've understood the concept how. And then tomorrow on Monday, again, we'll not have any meeting on Saturday. That's only your exam. You'll be with John. After your exam, you're free to go. Okay? It's time for you to rest. Use the lab session if, for example, you finished early. Use the lab session as like celebrating. I guess it's important, guys. It's very important to celebrate small wins. I'd be very, very um I'm thinking about the term. I'd be very particular about that. Celebrate small wins. Allow yourself. Well, if you fail, right, you are you are punishing yourself, right? That's the often that's the reaction most of the time. So if you have little successes, celebrate them, savor the moment, so that you'll be addicted to it. You'll be hooked. Okay, I want to be successful in this. Even small things, it would pile up. It would pile up. I assure you that. I assure you that. If you just know my story, my story when I started this career, those small wins, those are very important. Imagine it's stacking one by one until you achieve this major success. So those small steps, those baby steps, baby successes are very important. So make sure to celebrate them. Celebrate your small wins. So yep, I think that's all. On Monday, we'll be starting with SQL codes. Okay? Okay, guys. So enjoy the lab session today. And that's all for the lecture. Thank you very much.
John, I mean, Jeff, I have a question.
Yep.
Um, I was planning on doing a road trip for Saturday. What happens if we cannot attend a test day?
Okay. Sure. This is what I do. You can take the test on Monday, right, John? You can take the test on Sunday. So in order
On
for
Monday.
us, sorry, on Monday. So don't post, John, the questions on Canvas or wherever. I'll be sharing to you and maybe send them to their email personally. Okay. So that way, it would be still um, like new to Grace on Monday. Okay.
Okay, I'm going to try because then the departure time can always change, but we'll see. Um, but so how does it work with the exam? Like, it will just be downloadable, and then we work on it ourselves.
Yes.
Takes a couple hours or something like that.
Maybe it would take you at least 3 hours to complete.
3 hours. Okay, and then the
Yeah.
idea is John is there if we have questions, or it's a no question because it's exam, or just what to expect for exam format?
No, John is only there if you have some clarifications about the question. But John would not help you, like, since this is an exam, John would not be helping you answer the questions. Only John is only there as a proctor. Okay.
Okay.
Yep. So don't worry, Grace. I'm completely flexible with it. We have experienced that in the past. That we know you're adults. There are um outside of the class, other you have life too. We know that. So we'll look for ways. So on Monday we'll be giving you the exam, and there's nothing there's no issue with that. It's perfectly fine.
All right. Thank you.
Sure, sure, welcome. So how about the others? Do you have any concerns or questions? Again, you're not competing with each other. Let me remind you about that. You're not competing with each other. We're not. I'm ever since I started teaching, I always remind my students, you're not competing with each other. You're competing with yourself. So this exam is it's a form of self-evaluation so that we can see your weakness points, your strengths, so that we can sort of use that information to move forward. So you're not competing with anyone here, only with yourself. Remember that. Okay, I think hearing none, I think everything's clear. Let me see the chat box. Anissa says, "Thank you." Yep, thank you very much, guys. This this flu is really bothering me. If you can feel, maybe you've experienced that in the past. It's quite annoying. Like my voice would be suddenly disappearing. It's very painful. Very, very painful. So, yep. Thank you very much, guys. I hope this session is great, and see you on Monday. Bye bye.
Thank you, sir.
Bye.
Hello, everyone. So, we have 6 sir. Do you want to have a quick break before we transition to the lab? Or do you want to continue?
Let's just continue. That's my vote.
So, okay, how about the others? Let's just continue. Anissa? Okay, okay, so, okay. Okay, so that's good. So, for us to complete the activity that was left to us by Sir Jeff, I sent the screenshot on the chat box. So you can see that chat box ERD for a retail store inventory management system. So we can do this activity on the visual paradigm site that I sent also on the chat box. So let me uh, open the link first. So on your browsers, when you type or when you search online visual paradigm, it will be the first thing that will show up. The visual paradigm online productivity suite. So if this is the first time that we are using this, we need to sign up for an account. So let's see. I think get started for free, and then there is a sign up button there. Oops, since I have an account, you will not be able to see the process. Let me use another account. Let's try this one. So visual paradigm. That's the name of the site. Visual paradigm online. Paradigm online. So the first link that will show up is the thing that we need. And this should be the interface that you will see. There is a sign up and there is a login. And since we are just this is the first time that we will be using this. Need to click the sign up. So try to create an account first, and then I will show to you where are the ERD part, the entity relationship diagrams part. And let me know if you are done on creating your account. I'll share my screen.
John, we will just be doing this ERD thing today. Not touching on the lab 6. Is that
So
correct?
after we finish this lab, if we still have time, we can try to answer the lab 6. If we still have time. If we can finish this early, the ERD.
Okay. If not, the due date for that is by Saturday or Monday?
Do you have some do you want it to be adjusted until maybe Monday? Okay, let me know if you would have some challenges in completing it, and we can still move it until Monday or Tuesday.
Okay.
But
Right.
the first parts of the lab 6, I think I discussed the first parts on the
Yeah. And
meeting
but then the
yesterday.
last one is
Yes, the
the
last one.
scenario manager, which is the part
Oh,
that
okay.
you didn't get covered, but I was like, oh man, this would be the nice one to see. But
Okay.
maybe I can just YouTube it. I guess it'd be nice to have Thursday session, but yeah.
Okay, let's try to have some glimpse of it after we finish this activity. This will
Okay.
be very fast.
I'm available.
This
All
is
right.
this will be very fast. Are you done on creating your accounts?
I am diagrams
Okay,
looking, right?
thank you for that. Okay, so I think most of you are done. So we can proceed on the next steps. Where is my so the interface of the visual paradigm online looks like this. So at the home tab, it looks like this. And then what we need to choose here, I think, is the visual. This one visual, and then we need to find wait, diagram, not visual. Diagram, and then we need to find the ERD. So it is on the second page. This one, entity relationship diagram. And then from here we can create blank. Okay, so we can create blank. And then you would see the tables, the connections, so we can adjust them. So let's say you want to add an entity table here. Okay, let me do an example. Just one example, and you will create the rest. Let's see on the chat box. Is it? We have a product, a product table which has these attributes. The product which has a product ID, name, description, and price. So I will click this. Automatically, there will be a pop-up table here. We can adjust each size. We can edit the text inside it. So I will edit this and name it as product. And it can also adjust its sizing. I think this way. Oops, how can I adjust this? Let me check. Okay, we can adjust its size, the 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 size of the text. So this is for the name of the table. And if we want to have some attributes here, I think there is a text box. So this one, a text. When you click this T icon, there would be a text box that you can also drag anywhere. Where is it? This one, and then let's say product ID, also the name. What else? Description and price. Description and price. So you can type it like this, like just like this. It's okay. We don't need to type here the data types because we don't have any idea on that, on how was the name was recorded. Is it a code or the actual name? So I think we can also adjust its arrangement if we want it to be left, the center to the right, and so on. And this is already one entity. So however, the problem is if you want to drag it somewhere, like you want to put another entity here, another table here, and another table here. When you adjust something, you need to also adjust the text. So that's the only uh, thing that we need to take note of that. And about the connections, let's say I have another table here, and I will just, for example, this is another table, and I know that between this table and this table, the connection is one to one. I will just click this one. So since this one is connected, I will click the first one and drag it towards the other one, and it will automatically create a connection. Like even if we drag it on another place, it will still follow. So if you want to delete it, just hit the backspace on your keyboard. So yep. And last thing is if you want to save it, you have an export button here, and I suggest save it as PDF. Okay, so that you have your own copy. You can also save it as an image, but I suggest you save it as a PDF. Okay, so maybe that's it for that activity. And let me know if you can complete it by 20 minutes, I think. I think we can complete that by 20 minutes. And by that, we still have 30 minutes left for lab 6. Okay, so I'll keep working on the EIB first.
So after diagram, what should I select? I forgot that part.
After the
Diagram.
which diagram? The one that after you finish creation of the diagram?
Yeah, so I create diagram. So there are lots of diagrams. So should I select? Which one should I select? Like
This one, the
component
first one.
diagram, the first one, class diagram.
Wait, which one? Wait, this one?
Sorry, John, I'm not
Um,
seeing your screen. I'm not seeing your screen.
wait.
You're gonna select ERD.
Oh, okay, I see. I see.
Yes.
Wait, go
So
to
diagram,
Okay.
yes, and
go to
then the second
diagram.
on the second page. Diagram, and then you can scroll some choices here. It's actually on the second page. And then click create blank.
Create blank. Oh,
Yes,
entity. The entity.
yes. And it will look like this.
Then Okay. And then create the box for product, right?
Yes. So you can just use the first one. You can directly drag it on any parts of the screen. You can resize it. So if you want to delete it, just select that table and hit backspace.
Wait, which one are we? Are we doing the?
This one. Oh wait, this one.
Okay, so entity we're creating product.
Product. But overall, there are three tables: product, category, and supplier.
Category. So are we just creating those first, or do we have to put the attributes in there too? I think you're on mute.
And I'm on mute and I'm not sharing my screen. Sorry. So okay, let me go back to this. So after you created your table, let's say this is your product table, you can have a text like this key icon here. So you can drag it on the middle, you can adjust its size and edit the attributes. Or you can just directly type the name, the product ID, the price, so on. And then after you created all the tables, you will now determine what's the connection, what's the relationship between the tables.
John, when we draw the arrows, it matters the direction, right? How to read the arrows?
Let's try to do so so the first table that you would select, like for example, you will use one to many relationship. One to many relationship. So the first table that you would select is the one that will contain the single part, this one part, the dash part. While the second one will contain the many.
Hold on 1 second, because
Many
you're not, I can't see. How do I go to factory? Okay,
May-
so it's the
yes, yes.
1-to-1 first to show that each product belongs to a single category.
Then how can I share to you if it's correct or not?
So are you done on your assignment?
Yes, like
At
I'm
first
okay with
you
this.
can you can take a screenshot and send it to me on the Discord privately so that I can take a look at it first.
How can I do a screenshot from laptop?
There is a button on my case F11 that has a text PRTSC print screen.
I'm sorry, I think I had bad connection. I cannot hear you.
There is a button on the laptop on the line, I think F11. It is print screen. So you need to find this button. Wait, let me send it on the chat box. Or you can also try. Wait, are you using Windows device?
Yes.
You can try. You can try on your keyboard. You can try the Shift Windows button and then S. Three buttons at a time. Shift Windows button and then S.
Hmm.
And it
Yes.
would look like this. Can you see it? That I can took part of the screen. Let's say uh, like Shift Windows button and then S, and it will look like this. Wherein I can drag on my screen what I want to screenshot, and then go directly to, let's say, the Discord. Let's say this is the Discord. You can just click Control V, and it will be pasted there.
Okay.
Let me see it. Discord. Okay, let's see. Each product belongs to a single category. Each product category can have multiple products.
Name.
Product is subtype. Product is subtype. Okay, so I already saw your work, Asiba, and so far the entities are correct. The connection between it is true that there is connection between the product and the category, but you can review its type of connection. About the connection between the rests, you can check if you are near to its correct format.
So
The connections only.
you're doing it again, okay, for us. So I'll
Yes, yes.
see.
I will
Okay.
also show how to do it.
Okay. Okay. Thank you.
How about the others? Grace, Jeff,
I
I
don't.
think I
Mia.
got it, but
I don't feel like I know anything.
So
like
Jeff
it feels to
got
me
it.
product and a category is the same relationship of product and a supplier, right?
Yes, yes. So one-to-many relationship. So one is to many something. But what's the direction? That's the
Huh?
important part. The direction is the thing that you want to check.
So it's the three. I mean, I only like I'm the way that I see it is like the one with the three the with the triangle. That's gonna be
Mhm.
on supplier and on category, and then the other like the just the regular cross, the regular line is going to be at product, right?
Okay, let's see. How about thank you for that, Jeff. How about Grace? Do you have any progress
Um,
on
so I have the 3 boxes with product in the middle and then
Mm,
2 lines from product to category and 2 lines from product to supplier. But of the 2 lines in between, one of them is a one to many, and then another line to present the one to one.
so you have two lines on the two entities. Okay, so
Yeah.
okay. Let's see that also. How about Mia? Hello?
And I shared mine with you on Discord. I sent
You
this.
also said it.
Yeah.
Are you the AK two three
Wait,
six
how
eight?
did
Um
That's me, Hasiba.
ah wait. Mia. Maybe you shared it on the class. Wait. Oh no. Where did you send it? On the Discord?
Uh, I'm rechecking 1 second. I logged out, so I'm gonna log back in.
So while we are waiting on Mia, how about you, Anissa?
I don't see any. I just see John's upload about the mode. Is there a way to
wait, so how
refresh
did
Discord?
Just the only thing that I am seeing is
where do we actually upload this?
I I think you need to submit it on email, or I will just create another tab on the Canvas so that you can have your you have a place wherein you can upload your works. But before that, let me
So just save this from the
check the
visual
other
diagram
files.
and upload that, right?
Yes, but I will create a place wherein you can upload it first. Let me see it. Oops, this one. Okay, so I think we can proceed now on doing the doing the ERD. So I can share. I think I can share it now because you already tried it. But if you want some further practices, I can ask Sir Jeff about that. So
Well,
uh,
didn't you put another practice in the chat about the students' university or something? So that could be a
yes, the
second
first one.
practice.
Yes, you can also try this one.
Yeah,
Uh,
university database.
yes.
But yeah, I think we all
Mm,
need to see what this first one looks supposed to look like.
but let's focus on this one. I think this one is much easier compared to this other one. So the key here is the relationship. Okay, so for now, I will just create three entities, which is product that contains these specific attributes. Can you dictate the attributes? I don't know. It is product ID. We also have the name. What else? The price,
Description and
description, and then
price.
price. Description and price. Okay, so I can adjust this first so that we can see it clearly. Okay. Well, this one I need to be smaller. Maybe 14. Oops. Oops. Okay. I think this one is fine. And I will just create another table here, which is for say the supplier.
Category.
Okay.
Supplier.
Category. What are the attributes of the
Category
category?
ID and name.
Those two only.
Those two only.
Category, ID, and name.
Si,
So
senor.
14. This one also is 14. Oops. Okay. This one should be say 18. Okay. So this is already good. And for the last, I will put it here. For the, what's the other one? Supplier.
Supplier.
Supplier ID, name, and then contact info. Supplier. So we have supplier ID, name, contact info. Contact info. So I will just fix it first. 14, and let's say this one is 18. Just for them to be uniform. Okay, so since we have these tables, we have these entities, we can now proceed to its connections. So first, each product belongs to a single category, but a category can handle multiple products. So a category can handle multiple products, but each product can just go to a single category.
Single category.
So based on that sentences, we know that the connection between these two is a one-to-many relationship. But what's the direction? So the direction should look
Category
like
to products.
this one, right?
One to many. Yeah.
Oops. Let me adjust this. So a single category can handle multiple products. Oops. Sorry for that. Again. That one. So a single category can handle multiple products. Okay, but each product, so we have many products, okay? We have many products, but each of them belongs to a single category only. Is that clear?
So that's only one
Based,
arrow.
yes, one arrow. So one to many. So one category can handle multiple products, but each product belongs to a single category.
Single category. I don't need to do double lines. Okay, that deep
Yes,
breath.
yes. So, okay, so let's proceed to the next one. Is this clear? The way we read this, a product, a category can handle multiple items like a category of on the sample of Sir Jeff a while ago. In the category of refreshment, we have a Coke, we have Pepsi, we have a juice. So there are many products that can belong to a single wait, those products can belong all of them in a single category. Okay. And in a single category, it might contain many products. So this perfectly demonstrates its okay. So how about the supplier and the other one? So let's read again. To determine what's the connection. So each product is supplied by a single supplier. So we know that the connection is between the product entity and the supplier entity. So going back to this, each product belongs to a single supplier, but a supplier can give multiple products. Okay, so one supplier can give us multiple products. So that is clear that it is also one-to-many relationship. One product is, of course, being provided by, in this case, single supplier only. Maybe that product is exclusive only for that is coming from this supplier, but that supplier has other products as well. Okay, so they are supplying many different products, but there is a particular product that is just supplied but by that particular supplier in this case. So we know that the connection is one to many, but what's the direction?
It should be the same thing as the category to product, right?
Okay, so like this. So one supplier can provide many products, but each product just came from one supplier. And since I'm not that focused on the class well, there are some matters that are thinking a while ago. Is the primary key and foreign key already introduced to you? Primary key
Yes,
and
yes.
okay,
You
so
mentioned all this.
this product, this is its product ID. It's that is its primary key, right? Also for the supplier, it is of course this one is its primary key. Also
In
for
the category
the
ID.
category, its primary key is it's the category ID. But since this category is connected to the product, there should be a column on the product that contains a linking item from the category. And the most logical connection between them should be the category ID, right? We should see on the product that there is another column that serves as the foreign key. Is that part clear?
Yeah, and it's the same thing with the supplier ID
Yes,
too, right?
in the supplier ID also. Primarily, these four columns, because imagine this is an entity, this is a table, and each of these is a column. Since it has connection to a category, there should be another column that would serve as the connecting column between product and category. Also, there
So
is another column for the product that will connect it to the supplier. So there should be another two columns here, right? And the most logical connection that we would create here is the category ID should be here and the supplier ID. But in this case, product ID is the primary key. Category ID and supplier ID, they are also IDs, but for the product, they are just foreign keys, meaning they are primary keys at other tables. So they should be present on the product as well so that they can establish these connections between the two. And we can further understand that real time once we start coding sequels, especially on the joins. So we will have a separate discussion on this. But the idea is there should be a connecting column between these two tables. That's why if the product is the main table, we should see a category ID there.
Essentially,
And on
in
the
this product
John, I have
entity,
yes, yes.
go ahead.
um so looking at this diagram, the so like in the first entity, name is going to be a column because it's an attribute. So because
Yes.
name exists in each of these entities, wouldn't name be one of the keys because that becomes your joiner or
Okay. So
something like that?
that's a very good question. So the connection does not rely on the name of the column. It actually relies on the contents of each column. So even though they have different namings, as long as they have the same contents, the softwares are smart enough to join them. But for example, on the case that, of course, the name of the product, the name here contains different contents compared to
Description,
the
yeah, then the
name. Yes,
category name.
on the category. When we create a connection between the two, it will give us an error. Just like what happened on, if you still remember the demonstration on the Excel, wherein Jeff asked something about what if we joined two columns that doesn't have any connection. So it would give us a message that these two columns or these two tables doesn't have connections based on this column. So the name of the column doesn't matter. What's important is the details under that column. So the information under that column.
Right. Should we add category ID and supplier ID to our entity product entity?
Yes. And I think there should be also product ID here. Product ID. Or let me think. No. It's okay already. They already have a connection using the category ID and also the supplier ID. So this one is enough for our simple database.
So essentially, inside this product entity, the product ID will be unique, and the
Yes,
category
yes,
ID and
yes.
the supplier ID award will not be unique. There will be
Yes, yes, yes.
multiple of those, same category ID, same supplier ID. Right.
Yes, yes, exactly. Like under the product, let's say you have Pepsi, Coke, orange juice, lemon juice. So each of them are different products. But there is a possibility that all of them are provided by a single supplier only, or all of them belongs to a single category only. So under the category ID, you would see a refreshment, 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 and then you can also see supplier A, all of them. All of them are being supplied by a single supplier. So the key takeaway is if that on this table, if that is a primary key, it is unique. So the product ID is unique in this case, but repetitions in the category ID and supplier ID is allowed in this. But on the category table, repetitions of category ID is not allowed. Okay. If that is a primary key, it should be unique. But if it is a foreign key, it's okay to repeat because multiple products there is a possibility that all of them belong to a single category only. Okay, so what else? Do you still have any questions on this?
I was just wondering how do we turn this in? Do we need to turn that in or?
So we can click the export and then save as PDF, and For now, please turn it in on my email. I will just record it. Or I will just create another assignment tab on the canvas so that we would be organized. Okay, let me do it real quick. Maybe later. For now, please hold on to your, please save your files on your computers. Maybe later I will try to create a tab wherein that is where you will upload your assignments. No, this activity, the ERD. For now, since we still have time left, I want to discuss the the last part of the lab 6 about the what is this scenario manager. What do you think?
It's not done.
So for the ERD, you can copy this because this is just a practice. You can replicate this, and this is the one that you can submit on the tab that I will create as part of the participation. And yep, but for now, please save it on your computers and upload it once I created the tab. So let me open the lab 6. I think this one. Let me see. I think this one. The scenario. All of this we have done this yesterday. So the only thing left on this first part of the lab 6 is this part wherein we will use scenario manager. So scenario manager, to have a review, it is used if you have choices. If you don't know the outcome, but you have choices, like in this particular activity, on this particular task, we have 3 different choices. We need to create 3 different choices. First is operating cost is reduced by 10%. So let's take a look on that. So operating expenses is reduced by 10%. So instead of 6,500, it should be, I will just create a simple formula that will have a discount of 10%. So original minus 10% of the original. So that's the exact meaning of 10% discount. So instead of 6,500, we now have 5,850 for the operating expenses. What's the other choice? Operating cost again, but now 15%. So same strategy, original price minus 15% of the original price. So 15% times the original price. Okay. So this is the choice 1. This is the second choice. And the third one is unit price increased by 5 and all the others remain the same. So all of it are the same. However, the unit price will increase by 5. So instead of 30, we have 35. So that are the choices. So we just interpreted what the question is saying to us. Like this is its breakdown. So option A is from 6,500, it is 10% less. Option B, instead of 6,500, it is 15% less. And then the last one is we have increased on the price quality, price per quantity by 5. So this is option C. So since we have many choices, we can use the scenario manager. So on the data, we can click what if analysis and then scenario manager. And then From this, we can add scenarios. So scenario A is done by changing the, let us analyze this. What's the end part? Before that, let me analyze first this. Maybe we want to determine what's the total profit for each of these choices. Okay, so this is the thing that we need to change, the total profit. Okay, so let's see. Data, what if analysis, scenario manager. And then we can click add scenario A. Let's say scenario A. We want to change cells, this one. And instead of 6.5, we want 5.850. 5.850. So add. Another option is option B. We are changing the cell B6, okay, to 5.525. Then, okay. And then we can also add another scenario wherein the thing that we want to change is price per quantity. So scenario C, but this case we will change this cell. Oops, I think I got the wrong cells. It is mixed up. The thing that we want to change is the B11 cell. By changing, okay, let me repeat it. Sorry for the confusion. So scenario A, scenario B, scenario C. I think this one is clear. So data, what if analysis, scenario manager. And then I will delete this first. So we will have the fresh start. So we can add a scenario name A wherein we want to change this cell B11. The total profit is the one that we want to change. Oops. This one is confusing. I did this yesterday. Wait. Data, what if analysis, scenario manager. Enter the values of each changing cell. 5,850. Let's see. That is one. B. Not the F3. Five five two five 5525. So C, we want to change this part to from 30, we want the 35. I need to edit this. To 5,850. Okay, so let's see what would be the result. So we have successfully changed it. 5525. Okay, so I think I got it. Let me clear this part. Is it not? It is not clear, right? So let me repeat it. Do not mind of this part because we will just use this to determine what are the new values. So data, what if analysis, scenario manager. So I will just let this here. So this should be what it looks like. So we want to add some scenario. Let's call scenario A, in which we will change this cell. So from 6,500, we want to see what would be the result if it was lowered by 10%, which is 5,850. So I will click OK. And from 6,500, I want it to be 5,850. Okay. So I can click OK. So that is for the scenario A. We can click add again. And I want to change, I want it to be named as scenario B. I want to change the cell B6, this one. And from 6.5 again, I want it to be less by 15%, which is 5,525. So from 6.5, I want it to be 5,525. Okay. And then we have the last one. We want to add the scenario C, wherein, in this case, the thing that we want to change is the price per quantity. Wherein from 30 per quantity, we want it to be 35. So we encoded all of them. So what would be the result if we applied scenario A, which is less by 10%, scenario B, which is less by 15, and then scenario C, which is uh, 5 higher than this 30. So when you click show, if you less the operating expenses by 10%, this should be the total profit. But what if 15%? You will click B, then show. If you less the expenses by 15%, this should be your total profit. And if you click C and you want to show its result, so as you can see from 30, it became 35, all of them stays the same, and this should be your total profit. If you want to show all of them simultaneously, you can click summary and okay. So this should be the summary. Okay. These are the changes, the highlighted cells, and that will be the result. I'm not sure if I explained it clearly, but since we don't have time left, if you want, you can review it on the recording. And maybe next time I will also explain it. Okay, so I will try to upload it as soon as our meeting ended. Okay, so sorry for the confusion. The first part of my discussion is not that clear. So maybe you can consider the last part only. Okay, so with that, see you on
Hold on, John.
Saturday.
So
Yes,
though there is a lab 6 and a lab 6B. So this is inside lab 6B. The lab 6 we'll also do on our own.
yes. So there are two parts for the lab 6.
Okay.
Eh,
Thank you.
so thank you on that, everyone. See you on
Thank you.
Saturday. Thank you.
Hey, John, tomorrow we don't have class?
Yes, unfortunately, I won't be able to meet you tomorrow.
Okay,
So,
no problem.
okay, so, okay, thank you on
Mhm.
that. I will just give you some announcements on the Discord. Thank
Okay,
you.
thank you. Best of luck.
Thank
Bye.
you, John.
Thank you.